Question 3a is about the Large Hadron Collider, and in the presence of a suitably directed uniform magnetic field, charged particles move at constant speed in a circular path of constant radius. By referring to the force acting on the particles, we need to explain how this is achieved and why it happens. Well, the magnetic field is perpendicular to the direction of motion of the charged particles. A charged particle moving in a magnetic field experiences a force which is perpendicular to the direction of its motion. This provides the centripetal force to make the particles move in a circle. From the magnetic force on a charged particle moving at speed v, bqv, providing the centripetal force mv squared over r, we can rearrange for r, and as the mass and the speed of the particles is constant, and the field strength is constant, the radius of the orbit will also be constant. In B part 1, the charged particles travelling around the LHC may be protons. We need to find the centripetal force acting on a proton when travelling in a circular path of circumference 27 kilometers at 1/10 the speed of light. Well, circumference equals 2 pi r, and so to find the radius we can use this expression, and that comes out at 4297 meters. Then force is mv squared over r, the centripetal force. Putting in the mass of the proton, the speed, at 3.0 times 10 to the 7 meters per second, 10% the speed of light. This gives a force of 3.50 times 10 to the minus 16 newtons. In part 2, we need to find the flux density of the uniform magnetic field that will be required to produce this force. We also need to give an appropriate unit. Well, force is given by magnetic flux density times charge times speed. So rearranging, putting in the values found previously or given on the previous question, and this gives a flux density of 7.30 times 10 to the minus 5. The units are Tesla. In C, we're told the speed of the protons gradually increases as their energy is increased by the LHC. We need to state and explain how the magnetic field in the LHC must change as the speed increases. Well, radius is given by this expression as we found previously. So if the speed increases, the magnetic flux density must also increase to maintain a constant radius of the path.